if you were to walk up, and you had it down, seriously, if you were to walk up and have a down power line on a car, you may not know that car was energized. If you reach up and touch it, you become the path to ground. Like we talked about the bird and everything, you become that path to ground. So this thing's insulated right now, but as you walk up, like this little, our little model will demonstrate, you become the path to ground. So again, just like with the limb, the best thing to do, whenever somebody's involved in you drive up on a vehicle accident, I know you guys do that all the time. Drive up on a vehicle accident, everybody's going to want to help the person in the car. The best thing you can do to help them, though, is call us, let us make it safe, and then we can get out there and make sure we're not rescuing people. All right. Next thing we're going to demonstrate is the old turnout boot. I think you guys have probably moved on to like a leather boot now. Does anybody use a turnout boot like that now? They're still used. Yeah. Well, one misconception is that they're going to provide you the same level of protection like Ronnie has with his rubber gloves and sleeves. Remember, we showed you what a thorough check we do. In addition to doing a daily check, the visual check, the air check, we got leather gauntlets over top of them. We send our gloves off to our rubber goods shop. They're clean, they're tested, and boots, things can happen with them. You can wear a hole in one, you can get a needle or a tack, or not a needle, but a nail or something like that in the boot. And that's what we've done with this boot here. We've got like a little lag screw in the bottom of it. We're going to demonstrate how that you could become the path to ground if there was something wrong with the boot and you were to walk up like that car. We'll demonstrate how that boot could conduct electricity through you. Right. One thing, you guys all wear Nomex stuff, right? Another thing you notice, I don't know if you noticed or not, because it's kind of changed from the old uniform stuff we had. But all our guys wear fire retardant clothes. All of us have everything we have on. Even Richard's reflective vest there is fire retardant. And you guys are all familiar with that, but we use this also to help our guys understand why it's important that they do wear the right clothing. Fire retardant clothing, our outer shell has to be fire retardant. Anything underneath our undergarments have to be all 100% natural fiber. And the reason for that is if we were ever involved in one of these electrical arcs, or if something went wrong, we had a flash, we don't want the clothing that we're wearing. Like back in the day when Mark and I actually went through training together, but back in the day when we were going through training, we wore whatever we wanted to, pretty much. I mean, sometimes guys would wear nylon jackets and that sort of thing. So you get involved, you saw these arcs. If something were to go wrong, your clothes could ignite and catch on fire and make things a lot worse for you than they already were. So this wasn't a guy that had a bad day. This is just one we've used for demonstration purposes. We took a torch and showed that just what it'll do. It kind of crumbles a little bit. You can see right there, almost like burnt paper, but it won't ignite on you or make the fire worse. We use that. What we're doing now, I don't know if you guys noticed, but what we're doing now is we've changed the way we've got this thing fed. Before we had a little over 6,000 volts on it. Now we're going to put 120 volts on it just to demonstrate a couple fuses blowing, that sort of thing. Also, we talked a lot this morning about doing honeydews and that sort of thing around the house. Doing some digging. What should you do before you do any digging in your yard? What's that? Call Miss Utility. All right, for bonus points, who can tell me the number for Miss Utility now, the new number?
188.
That's the old number. I think that'll still get you through, but now all you got to do is call 811. It's a little easier. As I get older, it's harder for me to remember stuff, but now all you got to do is call 811. This shovel is actually an example of what could happen if you dig in. The thing about underground, it's great because you can't see it. That's the good thing about underground. You can't see it anywhere. The bad thing about underground is you can't see it anywhere. You can't tell where it is. So you've got a pad mounted transformer there, and this is a fairly new. How long has this fire station been here? This build? 3 years. So it doesn't take very long. We've got power lines feeding into that transformer. We've got power lines feeding from that transformer into your building. And there's no real way of knowing exactly where those power lines are right now. I mean, you can't tell. So the only way to really know is to get Miss Utility to come out and mark it. And like I say, this is actually a real-world demonstration of what happens when you dig in. In this case, somebody done some landscaping, the underground, it was an underground service, just secondaries going to it now. It's the same type voltage we have here. But remember what I told you, this is a real controlled environment. Steve's got a kill switch, it's real short. There's no amps on it, it starts at 0 amps instead of having a whole lot of amps going to a house or a building. So it's going to be a lot more control. But we'll just show you real quick what happens. We're going to blow a fuse here. So it's going to make a sound about like a shotgun. We're going to show you what happens if you, just like this guy did, you stick your shovel in the ground, you hadn't called Miss Utility to get into service going to your house. They want to cover your ears. Sounds about like a shotgun. I'll leave it up to you.
And y'all go hear the best of it. It's going to blow this way.
Yeah, it's going to make a little noise and a little bit of smoke.
Just stay right there, DJ.
Y'all thought I was kidding. I'll tell you something else. That right there, that's the reason why in addition to FR clothing, most of our linemen carry extra underwear with them.
Thing like that.
But yeah, anyway, once in a while we get a little fuse blowing on us.
Never counted on so very good.
Everybody all right? Everybody still with me? Hey Jim, you didn't have your earphones on when I had these.
I learned from this morning.
All right, the next one we're going to demonstrate. Has anybody ever heard a sound that sounds about like that, a shotgun going off and then the lights go out? What that is, that's a fuse inside that gray barrel we had there. We're going to demonstrate another fuse blowing here in just a minute. And this happens to us a lot more than we would like. When a snake or something gets on the line.
What is a squirrel guard?
Squirrel guard? It's like a piece of rubber that goes on the top of this, the high voltage bushing here. It's kind of screws down on top of it. And all that does is it provides a little protection, a little insulation. Of course, in this case, we don't have one, but we're going to demonstrate. We had, it's been less than a month ago, I got a page that a snake got in a substation, and we dropped about 2,500 customers out like from one snake getting in one of our substations. You know, the fenced-in areas with the great big gray transformers. I want to do a little disclaimer. No real snakes got hurt. Will get hurt during this demonstration. This is just old rubber snake with a since he is rubber, we do have a little piece of copper. That's a little bit of show business there. We got a little piece of copper on there to help him go to ground. But this does happen in the real world snakes. As you said, squirrels that get up on top of the transformer, raccoons, that sort of thing. So again, we're going to make a little sound. I don't know if you want. I'll leave it up to you if you want to cover your ears or not.
All right, here we go.
Pretty loud. All right. So what do y'all think of that? Time to eat. All right. I don't think he's going to taste too good. But anyway, all right, another thing, this time of year, and I know you guys just had some downbursts, didn't you? You had some little bit of outages up this way. Well, one thing we want to get out, particularly for our guys and for you as well, is a potential that's out there for backfeed. You know, I talked to you when we very first started this thing. This whole demonstration is actually done with backfeed. We're actually backfeeding this thing with a regular transformer up and doing this demonstration off the secondary side of your transformer. And we're going to unhook all our leads. He just unhooked our feed right there by creating that opening. He took that door out. And what can happen during a storm, particularly something like, I sure hope we don't have another Isabel, but eventually we're going to have some sort of thing. Last winter we were up here working ice and snowstorms. You guys just had a downburst. Last week, in the middle of the week, we were down in Tidewater. We had some pretty big storms come through. So we have down power lines, you know, pretty frequently. But what happens is a lot of our customers go out and get a generator. And as long as they take what we recommend with a generator, one is you get an electrician to go out and properly hook it up with a disconnect so they can't backfeed on us. Or, as a homeowner, you can plug an appliance directly in, like a refrigerator. Just plug that appliance directly into, so you take a cord, extension cord, just directly to an appliance. But you never just plug a cord into your house outlet, because it'll backfeed through our system, back through our transformer, just like we did. We're going to demonstrate that now with our voltmeter. Ronnie, you want to put your meter up there? Steve's going to fire this generator up, and you'll see how quick. So one of the things, you know, one of the major things I want to, if you don't remember anything else we showed you today, just because you've got a power line that you see that's down, never assume that it's because it's down on the ground. Never assume that it's de-energized or dead, because a couple things can happen. You know, mechanical things can fail. Someone can come out with a generator, and just because it's down doesn't mean it's de-energized. All of us can tell you stories about we've gone out after storms and seen things that surprise even us. That, you know, we're thinking, even though we have rules and we know what to do to make assure that it's, what we do is we make sure it's de-energized, it's tagged, it's tested, and it's grounded. In other words, we put grounds up like we've got going to that ground mat there to it. We know that it's dead, and we know nothing can backfeed on us. That's what our rules teach our guys. They go to school for 56 months, learn that. So never assume that. And even if it's down and it was de-energized to begin with, if there's not something like us out there with grounds on it, and some homeowner goes out there with a generator and fires that thing up in a matter of seconds, you saw how fast it was. It could go from being de-energized to energizes. I mean, just a couple seconds. So that's our demonstration.
With that generator running 7,800 volts,
Volts.
The
Well,
neutral
that's-
just has to return.
Yeah, that's a return.
It's bonded to earth. If it wasn't bonded to earth, voltage would rise on it. When it's bonded to earth, voltage can't rise, but current still flows through it back to the source.
so is it as dangerous as the hot?
If you had it on the ground and you put your hand on either side, you would be the path.
That's right.
Can you discuss single phasing real quick for the audience? I mean, we run a lot of commercial structures in Fashion Square Mall.
Yeah.
Probably about 10 months ago, we had a single phase incident out there where they don't have the phase protection at the mall at all.
Yeah.
But it ended up that Dominion Power came out and helped us out on that issue.
Yeah. If one phase goes out, our transformers have really 3 little transformers inside them on a 3-phase, and the neutral leg is tied together from all of them. If one goes out, it backfeeds through the other coils. So we could have, let's say we had underground, like feeding your transformer, we could have one phase cut. You could hear a fuse blow, but that wire would still be hot because the coils in the transformer are re-energizing the wire and backfeeding. So even though you see a fuse open, that doesn't mean the lines are dead. You can still have backfeed on.
And explain to them, Steve, what the customer would see on their side.
Yeah, they would see partial lights.
Yeah.
Mhm.
A lot of your commercial motors, like your air handling units and
Burn 'em
stuff,
up.
you'll
It'll
start
burn 'em
seeing
up. It'll burn 'em up.
anything that's 3-phase, you'll start seeing motors and valves and stuff burning up.
And that's their choice if they put protection on them or not.
Yeah. Well, in this case, they didn't.
Well,
A lot of cases
that was their choice.
Yeah.
So,
I have a question.
yeah.
How common is it in storm conditions that you find that your power lines energise other cables or other telephone cables and stuff like that? How common is that?
During a major event, it's very common.
So would it be wise to assume that when we turn up the telephone cables on the ground that they could be energised?
Yes.
That's the best assumption. In fact, we have a rule that our guys won't get on any, what we call foreign conductor, because other than ours, whether it's cable TV or telephone or something like that, we won't get on it without rubber gloves and sleeves.
Okay.
Because we assume because it's up an energized pole. We talked about that earlier. Just you may have a down telephone line here,
Yeah.
and you look up and all of our lines look like they're in good shape.
Yeah.
But that doesn't mean that a mile down the road or half a mile down the road that one of our power lines couldn't be down and get into that telephone.
Because that was my rule of thumb, always assume that whatever cable it is, it could be energised further up the road, right?
You're exactly right.
Yeah, and if it's high impedance on those lines, they will stay energized and won't operate our protective devices. It'll just, our system will see it as load and keep pumping juice into it.
So you sort of answered this question before, but my understanding is just a house current. So I think of the hot wire. If the hot wire is laying on the ground, it trips something. And so, but apparently that's not I understand about how philosophically that's not a good rule of thumb. But it's possible for an energized line to be laying on the ground and something's not tripped somewhere.
Well, it's kind of like Steve just said with the telephone. If it's not a good ground, our system is going to see it as load, and depending on how close you are to a substation, the more potential you have of current in that way.
Snow,
Yeah, it's
our
going-
lines
yeah.
will lay in snow and you cannot tell they're hot. They're
Snow's a
hot as
pretty
a
good
fire.
insulator.
A dry day, laying on pavement like this, they'll lay there hot, they won't arc. Now, if it's a little moisture, you'll see